And then we'll be reviewing tomorrow and Monday with your quiz on Tuesday of next week. So, probability you learned in Algebra 1. Those of you that took Algebra 2, you've also learned in Algebra 2. Probability is equal to, probability of something occurring is the number of favorable outcomes over the number of possible outcomes. So, most notorious is if you're rolling a die, what's the probability that you get a 2? Well, there's only 1 2 on this face. Out of 6 total, that's 1/6. What would be the probability that you roll an even number? 1/2, because 2, 4, and 6 are all even numbers, which would mean you have 3 out of 6, which is 1/2. So on the front, I just have basically a review of the algebra part of it, and then we're going to take and add in the geometry piece at the bottom. So I have a spinner example, which on your paper, they don't have color, right? So you might want to go around and label that these are purple, purple, green, purple, white, and purple, because if you don't look up at the board, you're not going to know what color is what. They all just look gray. So using the spinner to the right, find the theoretical probability, which means in theory. Does anyone remember what experimental probability is? There's theoretical, which is in theory what happened. What's experimental probability? Right? What you actually get. So if you were to sit there and spin the spinner 10 times and write down how many times you got purple, how many times you got green. So those are the 2 types, but we're going to be looking at theoretical only. So what is the probability that we would land in a purple region? How many purple regions are there? 3. How many total regions are there? 6. So 3 out of 6, which is 1/2. So again, it's the number of outcomes you want in the numerator out of the number of total possible in the denominator. What's the probability that we land on green? No? 2, 6, 1/3. Good. What's the probability that we land on a 5? 1/6. There's only 1 5. See if you guys can complete the rest of these, and then we will go over them and move on to the. Okay, so the same concept is going to apply today, but instead of seeing spinner problems, we're going to see area problems. So geometric probability, instead of being number of favorable over number of total, will be the area of the favorable region over the area of the entire region, so the bigger sheet. Okay, some of these will be easier than others. This one's pretty simple. Find the probability that a point selected at random, if we were just to like throw a dart, would land in the shaded region. So the probability of the shaded region would be to find the area of the shaded rectangle and divided by the area of the big rectangle. So you have to know all your area formulas to do these. Sometimes you'll have hexagons, circles, decagons, triangles. So all the area formulas will get like applied into this unit. Rectangles are pretty easy, so we just have to multiply. We have 18 and 12, and we have 36 and 24. Area for rectangle is just length times width. So when we multiply those together, we'll get 216 out of 864. Now, probability, again, can be referenced as a fraction reduced or as a percent, okay? So you could reduce this and get 1/4. Or you could change it to a percent, which would be to actually divide and then multiply by 100. If the directions don't tell you which one, you can do either. But it does have to be a simplified fraction if you do a fraction. I think on the homework, they do mostly percents, except for a couple that are in terms of pi. So most will be in percents. Now on the back, we have a dartboard. Dartboard's a square, 12 by 12, and then we have 3 circles inside. Blue circle, a yellow circle, and a red. Well, the yellow is just a ring, really, and the red is also just a ring. It's not a full circle. So assume that a dart you throw will land in the 1 foot by 1 foot, 12 inch by 12 inch dartboard, and is equally likely to land at any point on the board. We're going to find the probability of hitting the blue, yellow, and red regions if the radii of the concentric circles are 1, the yellow one is 2, and the red one is 3. Okay, so we're going to have 3 problems, so make sure you allow yourself enough space. So let's do the probability of getting in the blue circle first. So that would be the area of the favorable region, which is the area of the blue circle. I'll just put a B inside there for blue circle. Divided by the area of the whole region, which would be the area of the dartboard.
Please excuse the interruption. The AP registration is now over and students should be reporting back to class. Thank you.
So the area of a circle is pi r squared. So that would be pi times the radius, which is 1, divided by the area of the square, which would be 12 squared, or 12 times 12. So that would be 1 pi over 144. And then we'll do these as percents as well. So in our calculator, we would then take pi divided by 144, and then move our decimal place 2 spaces over, or multiply by 100. It would be 2.18, or 2.2%. Now the yellow and the red are going to be harder because it's not just area of a circle over area of a rectangle or a square. Because this is not a whole circle, this is just a donut or a ring. So how do I find the area of the yellow ring? How do I find just this part? Hint, I may need to add or subtract some areas together. Joseph?
Find like the area of it with the blue one and then subtract it from the area
Of the yellow one?
Yeah.
Subtract, good. So we're going to find the area of the yellow circle, and we're going to subtract the area of the blue circle. And that will leave me with just the outside part of the yellow circle that I want. That's the favorable region, all over, again, the total region, which is still the dartboard, which is your area of the square, 12 by 12. The denominator is going to be 144 for all of them, because it's the same problem. So the area of the yellow square would be pi times 2 squared, minus the area of the blue circle we found was pi times 1 squared, which is just pi, all over 12 times 12, which is 144. And then you can actually subtract these pi's because they're like terms. So you're going to get 4 pi minus 1 pi over 144, which is 3 pi over 144. Now, you do not have to use parentheses around this in your calculator, but it might just be better for you to always put parentheses so that you never forget, when should I use them, when should I not? It's really when it's in the denominator that you're dividing by something, but it might just be better to always use parentheses when you have two things together. So 3 pi divided by 144. Move our decimal 2 spaces, that'd be 6.5%. Last one we're going to find is the probability of hitting the red region. We also could find the probability that we don't hit any of the circles, too, if we wanted to. So how would I find just the red ring? Right?
Do the same thing, but instead of subtracting the blue, subtract the yellow.
Good. So you're going to take the area of the red circle, and then you're going to subtract the whole yellow thing, which would just be pi times 2 squared, which is your radius. So this would be area of the red circle minus the area of the yellow circle, all over our dartboard, which is 144. We figured that out enough. So this one will be pi times 3 squared minus pi times 2 squared. Yellow has a radius of 2. So that's 9 pi minus 4 pi, which will get me 5 pi. Divide those and then multiply by 100, and we should get, I believe, 10.9%. Now we're kind of out of space, but let's just talk it through. What if I wanted you to find the probability that it doesn't hit in any of the circles, that it would land just out here? How would I find the favorable? We know it would be divided by 144, but what would we do in the numerator? What would be the concept or the idea? We're going to subtract some stuff. The area of what minus what? Jeremiah?
I just have a question.
Yes.
Shouldn't we subtract the middle part too?
Okay. If you are thinking of that, then you would be subtracting the yellow ring and then the blue circle. I'm saying just subtract the whole yellow circle, which there's yellow like hiding underneath the blue. So I'm not subtracting just the yellow ring. I'm actually subtracting the whole yellow circle whenever I choose pi times 2 squared. Pi times 2 squared is actually representing this whole thing, even though it doesn't appear to be all yellow on our page. Good question. If you wanted to subtract the yellow ring and then subtract the blue circle, it would be the same thing as subtracting just the whole yellow circle. But if I just wanted to find how can I find this, the probability of this region? Mira?
The area of the whole thing minus the area of the whole rectangle.
Good. You take the area of the whole rectangle, which is 144, and subtract the red circle, which would be pi times 3 squared, like the whole red circle. All right. Then it says if you double the radius of the blue circle, how does the probability of hitting the blue circle change? So the radius was 1. So if we double that, that means the radius would be 2. So that would be pi times 2 squared divided by 144. And we should get 8.7. I think. Yes. How does that compare to the original? Yes?
You had 1 too many fours. You had 3 fours.
Thank you. Still will be 8.7. I just didn't even notice that was one extra decimal off. And that 2 spaces 8.7. How does that compare to the original probability, which we had up here was like 2.2? Remember, we rounded these answers, so they're not like exact, but how do those relate? Brett?
It's close to like 4 times.
Yeah. Why isn't it just 2 times larger? Like if you make the radius 2 times as big, why doesn't the probability just get 2 times bigger? Why does it get 4 times bigger? Because you're squaring it. Okay, 2 squared is 4. So whenever if you were to triple it, triple the radius, the probability would be multiplied by 3 squared, which is 9. So the relationship is because of the squaring. All right, the last one is a great question. Circle is inscribed in a square. So first of all, it's a square, so let's put 20 on this side also. Find the probability that a dart landing randomly on the target will land in the shaded region. So first of all, we need to find out we know the sides of the square. What would the dimensions of the circle be? Because they didn't give us anything. Mira?
The diameter is 20.
The diameter would also be 20. And therefore the radius would be 10. Okay, so do a little problem solving there to figure out. So how can I find the favorable region? How can I find this shaded region out here? And if you see white space in the middle, that means you're subtracting something out. Marquise?
The shaded region subtracted from the circle.
Yes. So we'll take the area of the square minus the area of the circle. That's our favorable region, which would be this part, divided by the total shape, which is the area of the square. And you cannot just cancel out the squares. It doesn't work like that. You have to actually calculate these. So the area of the square would be 20 squared. Minus the area of the circle would be pi r squared all over the square. So we get 400 minus 100 pi, all divided by 400. And then you can just put that all into your calculator if you want. Just put some groupings around your numerator, and you should get your percentage. Again, multiply by 100 or move your decimals, and we should get 21.46, so we'll say 21.5%. Now, all of the questions in probability can be different. They don't have to all have circles in them. They could have like a hexagon with a triangle inside of it. You could use all of your area formulas. Jeremiah?
I solved for the area